The lithium-ion battery has revolutionised technology over the past couple of decades. It has allowed for our small phones, our powerful laptops, our smartwatches. It's gotten far cheaper, far easier to produce. So, let's discuss how it works and why it's not an acceptable solution for the future of our energy grid. So, in this first diagram, we can see the cobalt oxide cathode, which is positively charged, and the graphite anode, which is negatively charged. So, when the battery is fully charged, the lithium ions are intercalated into the graphite, which means it's stored within the layers of the carbon, and there is a huge build-up of negative electrons on the anode. Thus, when we connect the anode to the cathode, which is positively charged, electrons are attracted towards the cathode, and we get a current in the wire. However, electrons build up on the cathode, and the cathode becomes more negatively charged. Therefore, we want some way to allow these positive ions in the graphite to get to the cathode, so we introduce an electrolyte. But we do not want the electrons to go through the electrolyte, so we introduce a semi-permeable membrane that allows the positive ions to cross, but not the negative electrons. When we want to charge the battery, we apply a voltage to the wire, and the process reverses. The lithium ions that were intercalated within the cobalt oxide travel back across to the anode. However, we can see issues with this process, especially if the battery is fully decharged to 0%. The lithium can react with the anode and form compounds referred to as solid electrolyte interphase. These compounds permanently take lithium out of the circulation, thus reducing the number of charges available to carry through the wire. Therefore, the capacity of your battery reduces over time. An even worse case scenario is when lithium builds up on the anode to form lightning-like dendrites. If these dendrites can puncture the semi-permeable membrane, electrons can flow through the electrolyte and cause a short circuit, which leads to battery fires and possibly explosion. This leads to an obvious issue with the lithium-ion batteries: the risk of explosion, the safety risk, especially if we are considering large grid-scale storage. The potential for a giant lithium battery fire producing toxic chemicals to kill all workers, animals nearby, big negative. Another negative for lithium-ion batteries is that they are currently too expensive to provide long-term energy storage, because they are not economic to store energy for more than around 4 hours. And the main issue is there is not enough supply of the raw materials to meet the demand. We will struggle to have our current materials reach the demand of the future EV market and the future mobile device market. Not to mention the grid scale storage that we will need to allow for our renewable revolution in the future. Therefore, we need to look at other forms of energy storage, especially for grid scale application.